Hello and welcome back to the Introduction to Ansible section of this course. In this video, we're going to be taking a look at how to really use Ansible. This video is going to be really lab heavy. We're going to spend a lot of time looking at the actual usage of Ansible and configuring a couple of devices and showing what the output looks like and some of the features available to us. Then we'll see how to execute and retry and also review the ad hoc modules and playbooks. So let's go ahead and take a look at ad hoc first and see what we mean by that. So ad hoc module execution is executing an individual module outside of a playbook. This is generally not recommended or really particularly useful for Juniper devices due to the amount of manual and custom configuration that you need in order to make this work. That you would use a command like this. You use the Ansible command and then specify the -m and the module name. You need to specify a user to connect to the device with, and the -k is to prompt for a password. And down here, you would specify the IP address or host name of the device within your inventory file that you should execute the module against. It does need to be listed in the Ansible inventory file. Additionally, for Juniper devices, the local connection type must be specified in your inventory file. So over here is a little excerpt of what an inventory file might look like, and that on the line of the device that we want to specify, we would have to say Ansible_connection equals local. And that would need to be on every line of every device that we run to specify the local connection type for. So for any of our Juniper devices, it would be all of them. It's a little bit of a pain to try and get this working. I had to play with it for a while to get things moving correctly because in addition to this, we also needed to save and accept the host key for SSH as it was denying by default. So you need to really connect your device first or pass an argument to your Ansible command here with custom SSH command arguments, which will ignore the SSH host key and not bring up that warning or fail the module execution because of it. So I don't really recommend it. However, it is possible to do it, so I did want to bring that up. Now, executing modules in a playbook. This is really where we're going to get into the meat of everything. So playbooks are executed using the Ansible-playbook command. You can specify a custom inventory file, as we had talked about our inventory files previously in the course here, and this can be passed using the -i argument. So you can also use the --list hosts argument to only show the list of devices that the playbook would execute against. Now, this does not actually execute the playbook, it just lists the devices that it would execute against. Now, you will specify your hosts within your actual playbook, and you can even limit your hosts with a -l or -l argument to your Ansible-playbook command there as well. As we see down here in our example command, we have our Ansible-playbook. We are specifying the YAML file of our playbook. This would be in the same directory as the one we are currently in. We are specifying a custom inventory file. Within our home directory, it is the my_hosts file. And then we are also limiting this playbook to only be executed against the hostname lab-1. So that's example of our command that we would use for executing a playbook. So now let's go ahead and just jump into our lab here. So this is the topology of how our lab is set up. we have two routers that we're interested here. That is Lab 1 and Lab 3. The loopback addresses of each of these have been listed here, and they are connected to each other both via gig 000. Gig 001 is used to connect to the switch here that our Ansible server is on from Lab 3, and gig 002 is coming from Lab 1 to connect to our Ansible server. Now, our goal here is going to be that we want to get loopback routing between our Lab 1 and Lab 3 here. So we're going to go ahead and create an OSPF area here. OSPF area 0, and we are going to add our gig 000 interface on each of our devices to OSPF, as well as our loopbacks of our two devices to our OSPF area, so that we can have loopback routing between our routers. And we're going to go ahead and push this configuration with Ansible to both of our devices. So this is going to be done by our playbook defined in our YAML file here called config_ospf.yml. And this playbook is going to use configuration that is specified in ospf_example.conf. It is actually going to pull the configuration out of that file and apply that to our devices. So first up, let's go ahead and just review the playbook here and take a look at what that's going to look like and how we're going to achieve this. So here I have our config_ospf.yaml playbook. We have one play in this playbook. It is called configure OSPF. Now our tasks are, we're executing this against the VSRX group, and we are using the juniper.junos Ansible Galaxy role. We're specifying that as a local connection as is needed for interfacing with Juniper devices, and we are saying to not gather facts of our local Ansible server. So we are going to prompt our end user for some variables for the device username and the device password, and it is going to save these into the corresponding variables that are available to our playbook here. And as we see, we have our provider info var, our variable, which the provider info is used by our PyEZ that we see here. Provider is the provider info variable. Now, you might notice that this is Jinja, and as we discussed in our playbooks video previously, that Jinja is parsed and executed against our playbook here to be able to fill our variables. So our host is our special variable inventory host name, which is the currently executed host. That is the special internal variable to Ansible for the currently executed host. And we have our device username and our device password, and then our port number that we're using. This is executing over port 22, so we are not using port 830 as our usual netconf over SSH port. Our tasks, we have two of them here. First is to load our baseline OSPF configuration. We are calling the Juniper Junos config module. The Juniper Junos config module has a fair number of arguments that we can apply to it, and that we are specifying a source file of our config that we want it to load and what the format of that is. We are specifying that it is text format configuration, and we are giving the name of the file, which will be in the same folder as our playbook. We are doing a load replace, and we are doing this in configure exclusive mode. We are specifying that we should commit this configuration once it has been loaded, and that commit should have a comment to go with it, that we are applying the baseline OSPF configuration, and that this is pushed from Ansible. Finally, we are registering the output to the Junos variable. And then in our second task, we are printing the diff lines of that output, which will show us essentially the show pipe compare of the loaded configuration. Now, I know that was a lot to go through here. Let's go ahead and take a quick look at our actual configuration file, the ospf_example.conf. And to do that, we're going to jump into our Ansible server here. We just do an ls. We've got our ospf_example.conf. So let's just do cat ospf_example.conf. Now, this is, text format Juniper configuration of having our braces that are appropriately indented to specify our configuration hierarchy and our semicolons at the end of statements within a configuration hierarchy. That we are in the protocols OSPF area 0 section of the configuration hierarchy, and we are adding interface gig 000.0 and interface loop 0.0. And just to confirm, if we go back to our topology here, yes, we do want to add gig 000 on both of our devices into our OSPF area 0 and loopback 0 of both of our devices so that we can have loopback routing. Now, going back to our Ansible server here, let's actually just take a quick look at our devices. So our lab 1, if we do a quick show route, we see we only have local and direct routes here. There is no OSPF running currently. If I do show OSPF neighbor, we can confirm that the OSPF instance is not running. And similarly, if I check on lab 3 and do a show route, that we also only have direct and local routes, and that if we do a show OSPF neighbor, as well, the OSPF instance is not running. Now, we can confirm that we're able to ping these devices across each other, that our local address here is the 10.0.1.9 address on the gig Ethernet 000 interface. And this is the 10.0.1.8/31 network. So the other side, lab 1, would be 10.0.1.8. If I do ping 10.0.1.8, I confirm that I am indeed able to ping the other side, which would be lab 1. 10.0.1.8 is assigned to that interface here. If I do a show interface terse, we can see that here as well with gig 000.0, there's 10.0.1.8. Excellent. So let's go ahead and apply our OSPF configuration here and see how we would do that. So we would use the Ansible command and specify our playbook. That our playbook is config ospf.yml. And actually, before we do that, let's take a quick look at our Ansible hosts file. So if I do /etc/Ansible/hosts, that our VSRX group has lab 1 and lab 3 in it already. Excellent. Now, we did specify Ansible connection equals local here because I was testing with the ad hoc module execution and decided that it wasn't worth doing a lab on here. It's just useless in day-to-day operation, that you wouldn't want to do that. So our lab 1 and lab 3 are in our VSRX group. And just to make sure, the VSRX group is what we are executing this playbook against as specified in the hosts section of our playbook. So let's go back over to our server and let's do Ansible config ospf.yaml, and that's all we need to do, and we can go ahead and press enter. Now, it looks like we need to do Ansible playbook, of course. Ansible playbook config ospf.yaml. Our device username is lab, and then our password. We see that it is executing the play configure OSPF and executing the task load baseline and then we got a changed on lab 1 and lab 3, showing that there was a change to be made, and that because of that, it did go ahead and commit the configuration, and that we see our diff lines here of the configuration that was committed. We got an OK on both of them and a changed. Now it's saying OK on 2 tasks because we got OK from our printing config diff and our OK from load baseline OSPF configuration. And then our load baseline OSPF configuration also resulted in a change, so that was listed in our play recap here as well. So let's just jump back on our device and do a quick show route. Great, we have some more information here now. So with our show route, it looks like that we are learning about the 192.168.1.3 address over OSPF. If I do a show OSPF neighbor, great, we are in full established state with our neighbor here over gig 000. If we check over here as well, and lab 3 is indeed showing lab 1 as a neighbor, that we can now go ahead and try to ping lab 1's loopback. If we do 192.168.1.1, we are indeed able to ping lab 1's loopback, and that we have loopback connectivity between our routers. So that's excellent when everything actually goes to plan, right? Let's assume that you are not able to reach one of your devices, or that there's some error that occurs. So let's go ahead and I'm just going to roll back our configuration here. We'll do a quick show pipe compare, confirm the configuration that we're rolling back, and do a commit and quit. Roll that back there, and let's roll it back here as well. Excellent. Configuration checkout failed for Juniper Stateful Redundancy Protocol daemon. That's interesting. Let's try that one more time. I may cut this part of the video out. However, this is an interesting troubleshooting. We are on a VSRX here. That if I go ahead and do an exit, let's do a commit check. All right, well, let's exit here. We'll do yes. Let's do a show system commit. We see our last commit via netconf was that the baseline OSPF configuration was pushed by Ansible. Let's go back into edit, do a rollback one, show pipe compare. Let's do a commit. Interesting. Without details. I'm going to need to look this up, and I will cut this part out of the video. Okay, and we're back. I ended up doing a little research on this here. It's a thing that can happen with the VSRX. This ended up being a little bit of a glitch. However, I found if I just delete the protocol OSPF, we see that we have the same output of edit protocols OSPF when we did the rollback 0 as well, of edit protocols OSPF, same output, but it commits successfully in that case. And then if we commit over here, that commit is complete. So no worries, it's a little bit of a glitch that happens sometimes on this version of Junos. That we're on the Firefly edition, so it's a little older, a lot of bugs still in there that Juniper hasn't quite figured out, but no problem. So to go back to what we were talking about here is to illustrate what happens when we run into an error. Is that let's go ahead and exit here. And let's exit our exclusive configuration mode on both. And let's do a reload. A request system reload. Request system reboot. And yes, we want to go ahead and reboot. And then since that is going down currently, let's go ahead and run our playbook one more time, and that it should fail against lab 1. So we're going to do lab, put in our password, and let these tasks try to execute. So we see that lab 3 was successfully changed, and it looks like we're hanging out here for a little bit, waiting to see if lab 1 is actually going to work. Now, of course, we did just reboot the device. Yup, so we expected that to not be successful. That it's setting that we have our unable to make a PyEZ connection, that there was a connection error, and that it timed out. That only one of them, and we have that it failed here. So if we actually do a list that this is not giving us here a retry file, however, it would typically do so if you were using the Ansible inbuilt module library and provide a YAML file of devices which you could retry which previously failed. Excellent. I really appreciate you going through that with me and taking a little bit of a real-world troubleshooting sidestep there. I hope that this has been informative for you, and I would like to thank you for viewing.